And get started. So you guys can come on over, have a seat.
Mark and Brian.
So Mark and Brian, actually I'll let you kick off with Mark and Brian, and then I'll circle back in because I'll do
that
some
works.
introductions as well.
That works. All right, so we're twisting up on this. Mike's not opening. I'm opening. So really quickly, I'm going to send out a link for it. Google I/O. We're partnering up with UCF on it. It's Thursday from 12 to 8. I have the link for it. Me, as in CloudSpace, got chosen. A couple other companies all partnered up, Echo, all partnered up to get this going. So we're doing an all-day Google I/O 12 to 8 on Thursday. So if you want to know about it, hit me up. I'll make sure I get you the Facebook link to it so you can RSVP to it. There will be food, possibly Google Swag. We've been working with the Google rep at UCF. So Thursday. This Thursday. 12 and 8. So if you want, you got to get with that one and Todd. But aside from that, if you guys remember a couple weeks ago, we decided to do an Iron Yard scholarship for the Ruby class. Well, what came out of that, we ended up actually having quite a few people who went through, did the essay. The essay was pretty much what you wanted to do, what you wanted to build while your time at Iron Yard, and what the outcome would end up being when you were finished. And we went through about 6 or so, was it about 6 probably? Yeah, about 6 or so. And we ended up with Mark Hawkins?
Mark Sadler.
Sadler.
Yeah.
Mark Sadler. Sorry, I'm horrible with names. So Mark Sadler. And really quickly, I will let Mark talk about what exactly it was that he wanted to accomplish.
Okay, well,
Need that and come over here. And hold that.
all right. Well, first of all, I would just like to thank CloudSpace for providing the $3,000 scholarship to help me with my tuition at the Iron Yard. I appreciate it very much. And in my essay, I don't want to bore you too long, but I came up with an idea. I've got a lot of ideas of things that I'd like to do. I'm relatively new to programming. That's why I'm at the Iron Yard. But I have various ideas of things that I would like to be able to build. And one of them is a website similar to Lumosity. I don't know if anybody in here uses Lumosity or plays the Lumosity brain games, but I do subscribe to the concept of neuroplasticity. I believe that the more that you challenge your brain, the better your brain gets, increasing your neural pathways, and that helps in all kinds of different ways. So some of the brain games that I'd like to develop are similar to what Lumosity does, but it's taking it a little bit in a different direction. Like one example would be in the area of memory brain games. Lumosity, if anybody in here has ever played Lumosity's memory brain games, they're basic memory exercises, and really you walk away from those with, I do believe, better memory, but my idea is to not only have just basic memory games, but memory games that you can actually take away some subject matter. So let's say, for example, you wanted to learn a language. So some of the memory games could be based on something like Spanish vocabulary, or just any subject. Music notation if you wanted to learn to read music. So by playing those games, not only would you increase your vocabulary in that particular subject area, but also you're building those neural pathways which help in other fields. I think memorization in my generation's view of learning has gotten a bad rap. I think now people are consider learning to be more about concepts. Concepts are important, but back when people were memorizing poetry and all kinds of other things, what they were actually doing was building neural pathways that were helping them in other aspects of brain processing. So that's basically what I have in mind, and I'd hope to start working on some kind of prototype while I'm at the Iron Yard and be able to put together some basic brain game to demonstrate what I'm talking about. Okay, thank you very much. I appreciate it.
All right. We're excited to see what you do. And then when you are done with the Iron Yard, Brian's going to drag your butt back out here, and you're going to give a talk on it.
Well, I hope I'll have something worth demonstrating.
I'm sure you will.
I'm pretty sure you will. Brian's a really good instructor. I'll be nice. All right, so now I'm going to let Mike take it away.
Alrighty. So today we've got a speaker who, for the cloud space folks that are here, and just to circle back, I think I know just about everybody in the room. For the folks that don't know Cloud Space, we're a web and mobile development shop. Obviously, we do meetups. We're a big part of the community. Appreciate everybody coming out. My standard talk of you should get up here and give a presentation, and a lot of you guys have, so thank you. And Caitlin will fill in on the community stuff, which she already did. So without further ado, I'm going to introduce somebody who I've worked with for a lot of years, have really appreciated over the years. And for the Cloud Space folks, this is the guy, along with the 3 or 4 folks that are sitting behind in the back there. If you ever want to know anything about me, I know everything, and they'll talk when my wife won't talk. So, but Ken and I have worked together for years, and they actually, Caitlin and Ken, put together this talk. I had no idea until one day I happened to mention his name, and she went, "Oh, that's the guy that's talking next week." So, so it's kind of it's a cool coincidence. But Ken, take it away, and I'll let you explain what you're talking on.
Do I have to click this thing somewhere?
Yeah.
That is the YouTube, so they can hear you.
Hey, YouTube.
Everything's live stream.
All right, so I'm not smart enough to.
Flip it on your shirt, and you can tuck that in your pocket or leave it on the desk.
I will tuck it in my pocket. I'm not sure where you're going with that, but. All right, guys. So my name is Ken Nordquist. As Michael said, I worked with him in a couple of places. Right now, I'm the director of application development for a company called TravelClick. Basically, we connect hotels with OTAs. For those of you who don't know what an OTA is, which is probably most of you, it's an online travel agency like Travelocity, Expedia, those kinds of things. So you want to put in a reservation, you log in Travelocity, you say, Dolphin at Walt Disney World, you put in the reservation, those messages would come through the TravelClick system. We'll send that off to the the property. So one of the things we found out so our monthly volume in there is about 150 million messages outbound per month, which is a lot, and it's growing. So one of the things that we looked at on how do we handle that, right now it goes through a Postgres database, which for those of you who know anything about lots of transactions through a relational database, that we have like issues on that. So we had a lot of learnings from that. We suggested Cassandra. We were politely said no, we're an Oracle shop, so we're going to figure out an Oracle way to do this. But our talk is going to be about Cassandra. So we're going to go over some relational database problems, why they don't scale. NoSQL, we'll talk about NoSQL. How many people know about NoSQL? Okay, so how many people don't know? Everybody else kind of in the middle, they've heard of it. So we'll talk about a little bit about Liz, Cassandra, some data modeling stuff, and then we're going to try and roll our own model. All right, so scaling. So basically with relational databases, the only way we can scale is up. So I can get a more powerful machine. I can get the best software in Oracle++, or I can get more memory. I can put more hard disk space on there. When it comes at a certain point, we will saturate the relational database. It also has, if you want to replicate, most databases are very, very complicated to replicate. So it's not just as easy as we'll just throw a couple more servers out there, and this server will always talk to that server. At TravelClick, we've had instances where we've had consistency issues. So if we have to switch from master to slave, we've had consistency issues. And complicated data structures. If anybody, I was looking for like the most complicated ER that I could find that would show like a really complicated relational model. So you have a customer who has invoices, and invoices have line items, and line items have products. So you can write this really left join kind of SQL query because we of that data. So we have to write multiple queries to get multiple views out of that. So we have problem scaling. It's difficult to scale horizontally, and replication is difficult, and we have some complicated data structures. So there's some controversy about the word NoSQL. And I'm kind of disappointed because my people in the back were supposed to hold up numbers on how I was doing, and I have not seen anything from them. So there's some controversy on what NoSQL is. Is it not SQL? Is it no structured query language? So people have agreed to disagree on what exactly that means. Basically, we're going to say it's not relational. So we talk about NoSQL databases, we'd say it's not a relational database. This part of the data doesn't relate to this part, another part. Basically, it's going to be unstructured, and it's going to be one, we'll call it like a blob. Has anybody heard of any of these? The document MongoDB? Okay. Has anybody ever worked with Mongo? So it's basically a document base that Mongo can build an index from the document. Key value, React. I'm a React fanboy for the key value pairs. I got one nod. I love you. I don't know who you are, but I love you. And graphs. Does anybody know what a graph database is? How that works? So basically, it's like a tree. It figures out how to do trees automatically, which makes things like like your friends kind of thing, like on Facebook, how you would associate friends and those kinds of things work really well with graph databases. And we have column databases, of which two biggies are Cassandra and HBase. The big difference on this Cassandra and HBase is HBase you need HDFS, the Hadoop infrastructure, so you can't just slap it on a server. Later, we're going to actually slap one on the server and see if it works. All right. And I've lost my mouse. All righty, Cassandra features. We've got the propaganda. Everybody can read that. If not, I can I can balloon it up, or I don't think anybody need to read this. It's a column-based data store, which means basically I can have one row that has as many columns as you want to put in there without having to change the schema every time I want to add a column. So I don't know those of you who have ever had to deal with the schema in a relational database, but you've got your perfect data model. Sales comes in and says, hey, we want to add this kind of feature to our stack. And then so you have to add a column or a number of columns. So you have to change your database. You have to go and do all these complicated migrations for those of you in a Rails ecosystem. And this will happen as your product matures. You'll get more and more and more rows. So now you have this really ugly database schema that probably 5 people know about. The 3 of those have quit and moved on, and now we don't know how do we work this data structure again. So some of the things we talk about is like automatic data distribution. The one thing that the big thing that Cassandra does really, really well is it scales, and it's almost linear. So if you have 3 nodes, you add a 4th node, you're going to get a nice straight line, basically. Replication, basically, you'll set up how many times you want to replicate the data. It is handled automatically. So if you have 4 nodes, you want to replicate 2, then you're going to have it's going to replicate automatically. You don't have to do anything. You have to be smart, and it is nearly linear scalable. And this is the Netflix. I have some references in the back. This is a nice this tech blog that Netflix did. This explains a lot of this really, really well and how it scales. So they're talking about nodes and replication and how many submissions per second they can handle. I would highly advise you guys to look at that. Okay, so how does Cassandra work? So Cassandra is really super fast in writing. That's the thing it does the best. It doesn't worry about, it's append only. So the first thing it does, we get some data come into the database. The first thing it does, it writes it to a commit log. It actually puts it on the disk. It doesn't do anything with that commit log at the moment. Then it writes something to what is called a mem table. So we're doing a lot of this, and we're doing most of this in memory. So first thing it writes it into the mem table, and it uses SS tables, which is it can order things in memory automatically. So it writes the commit log, it writes to the mem table, and then it once it has a certain amount of data, then it starts writing to the disk. But it keeps a lot of this data in the mem table. So if it needs to access it, it'll leave it in the memory. It flushes it from the mem table, then it writes it to the disk. And once it's been reading and writing for a while, it will compact. So any data that it doesn't need, it will actually erase from the disk, basically pull it off, reorder it, and then write it back onto the disk in sequence. The big part of this is there is only this append only. There is no updating. So in a regular database, if you want to update a row, you're going to have to go to that part on the disk. You're going to have to and just write into that little section on the disk. So every time you want to access that, that read-write, that head's moving all over the disk. With Cassandra, it's going to go, because it reorders it, it's going to go one part of the disk, it's going to read it sequentially, and it's going to send it back out on the writes. So writes are always super fast. And reads. Anybody heard of a Bloom filter? I got 1.5. And Henry too. So Bloom filter is it's a guy written by a guy, oddly enough, his name is Bloom. It's a probabilistic data structure. So it figures out like how should this thing be ordered, and it does it in memory as it's getting more data in. So the first thing we do is we check the Bloom table in memory. Is it there? If it's there, we're going to send it back out. If it's not there, then we're going to go check the partition key, which again is in memory. So this is the ordered part. So if it needs to actually read it, it's going to go to that place. It's going to read it from the memory and then send it back. If it's not there, it's going to read it from disk. And here's what it did a nice little job here on the dotted line. So we read from memory, then we check disk. If it's not in the disk, then we'll actually write it to the disk and then read it and then send it back out. So have I lost anybody yet? Yes, sir.
So the Bloom filter is just whether or not it's currently in memory?
So the Bloom filter is a way that it knows whether or not. So the Bloom filter part is it? So no. The short answer would be no. The Bloom filter is how it orders it. So that when it goes in, it says Bloom filter is it in this set in order? And if it is in that Bloom filter set, then it'll send it back out. If it's not, that's going to go to the key cache. Is that clear as mud? Okay. The way that the data is organized in Cassandra is by primary key, which is called a partition key. So whenever you order your data, you're going to order it by, let's say you want to have you have a customer base, and you would do customer ID. So the main way that it's organized on the disk will be by customer ID. So no matter how many columns you have, it will always write to that customer ID. So if you have customer 1, customer 2, customer 3, you upsert customer 1, then it's going to then once it compacts, it's going to reorder those for you. So when you hit customer 1, you want to read customer 1 through 10. It's going to read customer 1 through 10. Partition key. So when we do our data model in a little bit, we will actually going to put a partition key in there and look at it and see how it orders it in the database. All right, here's the fun part. So we look at data modeling on, does anybody have any like Microsoft or MS SQL and Microsoft SQL on actually writing a data model in a relational database? One? Okay. So we'll go through the 1.5. So we go through, like we have a customer and we put our customer data, his name, address, telephone number, those kinds of things. Then we have a customer is going to have many invoices. So I'm going to invoice you guys at the end of the class. So this will be a good little example. So customer is going to have many invoices. An invoice is going to have many products. So to have those display in the an invoice, we'd have to write a SQL script, select from customer, from invoice number, from product, from line number. So we have all this data that's in this really long SQL thing, or SQL statement. What we want to do now, and when we use Cassandra, whenever we use NoSQL, we want to write the query. We want the data to be in a queryable format. So we don't care how many, we can have the same set of data in the database 20 times. But when we have it written, we're going to have it written for the query that it needs to pull out. So for instance, when we have if we want to know the customer invoice numbers, those kinds of things, we're going to write that in one row, one time. So if we have 10 views, we can write that in 10 different databases. We don't care, because what we want to do is we want to get that data out quickly. Well, the other big changes, we're used to having DBAs. DBAs are going to enforce us or make us, think about how we want our data structured. So we write queries that the database and the disks and all that are working efficiently. Again, we're not as concerned with that now because we're going to do it programmatically. We're actually going to write the software to handle the model as opposed to having to write the SQL query, which looks at the data model. One of the big bonuses, we don't have to worry about joins. We have to be foreign keys. I don't need a DBA to tell me how great my database schema is or how awful it was. Or when you come in 5 legacy guys later, that the data structure for that query will always be the data structure for that query. All right, any questions so far? Databases, NoSQL. Henry said I'm lying. Thank you, Henry. Thank you, Mackenzie, for giggling. Okay, so we're good so far? Everybody? All right. So databases, we have types, so we can store a certain type of information in a row on a relational database. We have the same things with Cassandra, and these are the list of the types we can use. I don't think I need to go in those unless somebody has a specific question. We use a number, decimal, integer, blob. I just want a bunch of text in there, those kinds of things. But again, the part I really want to key on is how we partition the data. So when we set up the model, when we start setting up our model, we want to talk about how we want that data partitioned because we want it to be written as quickly as possible and read as quickly as possible. So because we have to do that programmatically now, we're not relying on the database to handle those decisions for us. We have to handle those programmatically. We really need to pay attention on how we're partitioning our data.
Are you reading individual records, or you eventually want to read it efficiently, sequentially? In most cases, you want to retrieve things for a particular restaurant, or in a particular hotel.
Okay, so I was just when I'm talking about the TravelClick thing, that's just like who I was or who I am. It's not. We didn't actually go down this path. Okay. We're actually sticking with Postgres and doing those things.
In some respects, the design depends on how you're going to, on the principal way you're going to retrieve these things.
Exactly. I mean, that is exactly it. Is how we're going to retrieve it. So I can have the same transaction in 20 different databases. Maybe it doesn't have this data, this column in this database, or it doesn't have this column in that database. But once it comes out, I can write it 20 different places because I'm optimizing for reads. I want to get this data out quickly.
Okay, you want to get a particular subset of the data out and avoid full file searches, or you're going to try and read it out in a particular order and get massive amounts of data in the reads, or you're just going to read the transactions that go to a particular hotel.
Okay, so if I was going to solve the problem of transactions for a hotel, so I would write it based on, we'd have to look at the partition key. As the transactions are coming in, I would put the partition key would be by hotel property.
Okay.
So then, we'll kind of go over that in the data model part. Well, okay, so let's go. All right, let's take that. So let's say we have a hotel. We have days of the week, or days of the year. So I can have 365. I have one column that has 365 data sets. And then I can have another column that has, let's say for one set of information, I have another column that has 365 data sets for another set of information. So when I read it, I'm just reading the whole row. I don't care what we pull out. When I pull that out, I'm going to send it over to the model, or wherever's going to process it. Then that's going to send it off, if we're talking to MVC, that's going to send it off to be viewed. But I don't have to write this really complex SQL that says join this, join that, join this, join that.
I guess the question I'm asking is, when you go to get a record, are you doing an index key search, or are you hashing right to or chaining right to a location?
I'm chaining right to location. Basically, we're going right to that place on the disk with that ID. We're reading the whole thing. We're not trying to pick bits and pieces out of that. We're just going to read the whole row. We're going to send that whole row off to wherever it needs to be processed.
Okay.
So it's really, really quick. It doesn't have to jump all over the disk to say, okay, I just want that column and that one, and it's going to join there, so I need to jump all over the disk. It's starting here, it's reading across, and then it's the head's going off the disk. Okay, clear as mud?
No, I see a design involved.
Okay. And it will, I think some of this will be, on, once we run through the data model stuff. So, what other questions? So Henry says, you have a question, Henry? Okay. And Andy spelled refund correctly. That's a big plus. All right. So I kind of went through that.
Two questions, Jim.
Yes, sir.
Real quick. One, you mentioned mem tables because Cassandra's storing everything in memory. Do you find yourself concerned about memory limitations for the size of these mem tables, these virtual tables?
So it would be tunable. So whatever concerns we would have, we would actually set that up in the as part of the configuration. We wouldn't just go, if we need 20 gigs of RAM, and we're worried about losing 20 gigs of data at a time, we would set the fleshing up to be a little bit quicker.
Question two, as you were addressing this gentleman's question, you mentioned that you could have databases set up, and this database would have this column, and this row would have different columns, and it sounded like you were dealing with databases that were out of parity. That sounded scary to me, or did I misunderstand?
So that's a really great question. So what we would do is we would have to set up the data models. We wouldn't necessarily need to sync that data. I mean, you could write stuff in there, programmatically to say, I want to make sure this data, if I have this row in this database, I have the same row in this database. Right. I'm sorry, replication?
Every time I think of
Oh.
replication, means this data exists in two places. It's been replicated.
Right, but what we're working with Cassandra is we're working on not the query from all the data where that would be important. We're actually writing a line or a row of data to solve a particular problem. And so maybe the problem we're solving, the data is duplicated. So yes, so if I was writing the software, I would write the software so that I'd maybe wrap in a transaction in the software to say, if I'm writing 3 different places, I better get a yes back from all 3 places before I write it and say that the transaction is completed. Yes, so we do that programmatically. We couldn't do that on the database. So that was the big key earlier when I was saying, was a lot of the stuff for now we're going to have to do programmatically. So if we do things software in a relational database, I can wrap in a transaction. That means if these 20 things don't happen, the whole transaction is nil from the database side, not from the software side. Any other questions? I kind of blew through NoSQL and the Cassandra stuff quickly. I wanted to get to the data model because I think that would be kind of fun. Everybody's good? Except for Henry? All right, so we're going to, as with all demos, our mileage may vary. And this is almost like Microsoft's little pre-picture. So does anybody have a problem they want to solve? Thank you for the rocket ship, Henry. Does anybody have a problem they want to solve so we can actually write the model to solve a problem? Or just want to go, I can go right through the tutorial that's on the website if everybody like. All right. Pardon me?
I say, I guess so.
Okay.
If there's anything you wanted to say, I know.
Okay, we'll go right there.
Man, I can't think of anything.
Darn. I was hoping you would. I was expecting you to.
All right, see if I can.
What are we right quick for a bank?
All right. This will be on the slides, and I'll clean up the slides a little bit, and I'll post those somewhere. But this will be, if you guys are interested in Cassandra, and we can talk after this talk as well on where all this information is. But this will be like the place to go. DataStax is the biggest contributor to Cassandra. They're also the biggest vendor. They've done a lot of really cool stuff. So we're we're looking at SQL. This is the Cassandra query language, which looks a lot like SQL. It doesn't do the same things underneath, but it looks like this. It's pretty much looks like the same. So there's a lot. It's an easier transition for those of you who know SQL. Does anybody know SQL? Okay. Okay. Michael Miller does. So this will be where we're going to. So when I looked for, so we've got some. So there are a few Ruby gems for Cassandra. DataStax has a really awesome one that will actually allow you to do futures, which is write something to the database, and then if you need a reply back, it'll wait before it wraps the stuff in transactions. It wasn't really helpful for what I wanted to show you guys, so I picked SQL, C-E-Q-U-L. It looks a lot like an Active Record. How many people are Active Record aware or, okay. So a lot of this, you have a lot of the same hooks in Active Record, you have a lot of the same data modeling stuff. It'll look a lot like an Active Record. So, class, we're actually adding the columns. We've got validation, those kinds of things. That'll happen programmatically instead of with the database. So SQL has a really nice little tutorial here. So we will use that. And I'm losing my cursor. So if anybody sees the cursor goes by, kind of wave your hand, say, hey, Ken, I went to the left.
You might be able to zoom in a little bit.
Okay.
Possibly.
Can we see?
Zooming in might help them. Is that good, guys? Okay.
Andy can see. That's good enough for me. So we're going to add this to our gem. Some of this I did already. Here's my gem file. Can everybody see that okay? What's that? I don't know if
You can zoom in that one.
I don't think JetBrains allows me to zoom in easily.
I think you can view settings, if I'm not mistaken.
All right.
Certain
Find my.
boxes that don't let you do it. That's what I'm calling it.
All right.
Look who just up. Shit, you're right.
Yeah. All right. So we're not gonna. It'll be pretty easy read. We're not doing really any complicated stuff, and so basically, what I would just want to show you is this is it. Gem SQL, and as for all you Rails guys know, you put Gem SQL in there, run bundle or update, that will install the gem for us. Nope, we won't do that. All right, so for those of you who don't know, up there, it's a new bundle. So I've already run this, so we're not going to see Bundy. And I will spell it right one time. So it's going to read all our gems. VAT, value-added tax. All right, our bundle's updated. We have SQL. We'll have all the good stuff in there now. So find my cursor again. And we will, I will do this a lot, guys. So we put gem in. I've already done the configuration, which puts in our. I do this up. And of course, we're going to go off the screen. I see Ruby on there. Ruby class. So I think we have people.
This is also a good point for those of you guys who get up and do presentations. When you're in a programming view like this, it's oftentimes easier to mirror your screen. It's
Yep.
really hard to operate the mouse backwards.
Word. All right, so actually that. So we're going to do a blog, and we're going to copy paste. Then we will run our migration for us. Has anybody like worked in Rails, put active record, done a model, run the, rake DB migrate, and see the change that happens in the MySQL database or whatever your database is? Okay, half? Okay. So the good thing about SQL is we can run the migration, and it will let us all right. It would be handy if this is larger. Can anybody squint and see this? Henry? No? Okay. So basically, when we're talking about our partition, so how are we organizing our data? We want to organize it, and the blog, we want to organize it by the subdomain. So what Cassandra's going to do is every row is going to be organized by the subdomain. So any columns we add, if we add more columns, they will basically be organized in the same spot on the disk for that row every single time, instead of, again, in random parts of the disk. So we have a subdomain, we add name, and they're all text. So we'll save this bad boy. And I'll lose my cursor again. See if I can spell bundle correctly this time. And for those of you who don't know, I can list all my rake tasks. Oops. Oh, good. Oh, thank you. This will list all our everything we can do. And as you see up here, we have the SQL. So we want to do SQL init with the bundle exec. Oh, no, we're not. First thing I'm going to do is install it. All right. So this is dead easy to install. That's it. It's a Linux box, by the way. I don't know if it works the same for Mac. The pen is mightier. Thank you. All right. Oh. And it's a Java application for those of you who don't know. So we're starting it up. It's going to create for us in all the right places. And we can see if I can. Oh, I'm not going to see it here. Anyways. So let me find my cursor again. There we go. And so this is what a SQL, this is what we're going to set up with the database on the development side. So we're connecting to localhost, Cassandra port 992, and we're going to, when we run the command, it's going to create these the database, the dev database for us, just like Active Record would for if you ran a regular DB migrate. All right, so we're gonna. This should create all the database setup for us. So we created the database for us, and it creates a schema for blog. So if I went in and changed the blog, it would update the schema for us. So all we have to do then is we just change the model. We don't have to write migrations anymore. I don't have to need to know that I added these columns or took these columns out or changed from text to whatever. Every time we run this command, the bundle exec rake SQL init, it will automatically synchronize the schema for us. So right now we have a blog schema in there. And now, I can find my cursor again. That was the part I didn't practice. So we had a nice little explanation on why we're actually on the key. So we're not using auto increment. We're not keeping track of this. We're keeping track of it by the subdomain, which is text. They're suggesting another one is a UUID. Does everybody know what a UUID is? Unique identifier based on some stuff in the dates. So this is a very basic record for us. So we have a blog. We got 3 fields in the model. So now we're going to go to a slightly more complicated. So again, those of you who have Active Record experience, you'll see this nice belongs to, which if we were going to write migrations and stuff for MySQL or MS SQL, this would have to be a foreign key that we'd actually have to explicitly put in our schema. So we have to write the schema, we have to get the model, we have to write the migration exactly correctly, and then we would have to have the foreign keys in there. We don't have to do that with the SQL database for Cassandra. Anybody have any questions so far? Guys aren't really like data guys, so I think maybe. Yes. All right, and as Michael said, it's a lot easier to do if I was facing it forward. I was trying to be smart and have my notes on here that you guys wouldn't be able to see.
Hey, can they make these things called prutters now?
3D? Sweet. How was that post? Voila. So again, we're going to create a post. So this is like a has many. What the difference will end up being is instead of having 2 objects that we're going to link together, basically we'll have one object that will kind of look like this. And then we'll have the post with all its information, and that will be one record. So every time we write, so if we have columns now, so I have post 1, post 2, post 3, post 4, post 5, post 6, that will be in one row of the database. So whenever I want to read for all the posts for that subdomain, I start at the beginning, I read all of the posts, and I send that off. So maybe on the controller side, we're only going to pull out certain, maybe Thursdays. I just want to know what's posted for Thursdays, or within the last 30 days. But I'm going to send that whole row over to be parsed by the software. We good so far? Okay. Thank you, Henry. So I'm just going to... And we're going to do this again. Oh, I blew it up. Oh, it won't. All right. So we synchronized the schema for the blog, and we've added the post. So now when we write data for the database for this stuff, again, it'll be the blog, and it'll be all the posts within the blog, because we went to the belongs to. Son of a biscuit eater. Sorry about my language, guys.
Have you not watched my YouTube videos?
No.
You've nothing to worry about.
Okay. Thank you. I almost feel better. All right. So again, we're not creating a table that has posts in it and then having to link that to a database table that has blogs, and then with relating that to a table that has posts. So I'd have to read blogs and I have to go over here and read the posts. Basically, I have all the posts within the one blog, so I'm reading everything at once, which makes things a lot faster. So now we're going to go and we're going to update. So I say, okay. Somebody says, no, I need to have those linked, and I need to know how I want to have better. Let me see mine. I'm actually kind of disappointed that my language isn't salty enough for everybody.
I dropped
Fudsicle. Okay, so again, we're going to, for those of you active record experience, we have a has many, which is I'm going to have one record will have many relationships. Come on, guys. All right. Hamby, I'm kind of disappointed in you.
I didn't write that one.
So, again, we made a change in the schema. We made a change in the model. We're not writing any complex migrations, and I don't need to worry about this stuff. And I've synchronized the schema for blog again.
Through Rails, we usually have adapter gems, like for MySQL2 is the MySQL
Correct.
adapter gem, which through the use of database YAML, we can use RakeDB migrate.
Correct.
We have the SQL adapter gem. Do we lose the access to DB migrate? Because I see you using SQL migrate. Are they interchangeable?
No, they are not interchangeable. So because in a relational database, we actually need to write SQL that will say, change this database so this table's in there. We're not doing that with CQL. We're doing it, it's different, and it's just one line every time. We're not actually overwriting data when we make that change. So we can add columns that will never be used in Cassandra using CQL. Where we have to pay attention to those in relational database world, we don't have to pay attention to those in the Cassandra world. All right. What time? Mackenzie, how much time?
You can go on a little bit longer if you would like.
Okay, so I was going to write a unit test, but I don't think we have enough time to write a unit test. Because that would actually, where the proof is in the pudding.
I can give you about 10, 15 more minutes. Is that on time?
No, no.
Yeah,
He's old, he works really slowly.
And the whole cursor thing's throwing me off,
No, you're fine.
Yep. Okay, so any questions on the data model, how we would data model, any kind of data modeling questions? Hamby?
Hey, so I do have a question.
Yes.
In the case of the data model where you're writing multiple blog posts, right, for this one line, what happens if you want to delete one?
If you want to what?
Wanted to delete one of the posts.
So in Cassandra, again, we're not actually changing a part in the database. We're actually rewriting the whole column. So let's say I have 5 posts, posts 1 through 5. You want to delete post 3. Basically, Cassandra will read that row, pull it out of memory, delete row 3 out of its memory, and then rewrite the whole row. So then what happens is it tombstones the old row for compaction later, and then it just writes that whole row again. So again, we have that start to finish on the disk space instead of having to skip all over the database.
You mentioned primary keys. When it rewrites, is the primary key of ID 3 still available, or does the old 4 become the new 3?
No, it would whatever key value we would have, whatever values we would have in that we don't lose those values. We only lose the value we're deleting. So let's say you had 20, 15, 04, 01, 04, 02, 04, 03. If we're deleting 04, 02, all it's doing is removing in that column 04, 02, it's just removing that and any data that was associated with that. All right. So I was kind of hoping we'd have more like data modeling stuff that we could have had a little fun on and maybe done trying to solve somebody's problem. I think we have enough background on like what Cassandra does. Basically, Cassandra is faster because we're writing one row that has all the information. When we read the whole row instead of having to skip all over the disk. We have the ability to replicate without a whole lot more overhead because this is what Cassandra does naturally. And it's super fast on writes because it's only writing with the whole row. It's not trying to figure out like what's missing and those kinds of things. Reads again are super fast because it starts at a place, it goes to the end of the row, and it pulls all the data for that. It doesn't need to know where on the disk a certain part of data lives. It's really dead easy in Rails. We just include the gem and then change the data model. And as we change the data model, we'll get new schema automatically. Any other questions? Any concerns? All right, I'm available after. So if you have actually some real live stuff, we can maybe, once the talk is over, we sit down and actually go through something.
With the way you're building this stuff, why would you not just write to a flat file system and store tens of millions of files on the file system?
So that for those of you who don't know, that was a troll.
It was actually a real troll.
Yeah.
Because we inherited an application that actually did that and literally wrote tens of millions of files in the file system. So why you would do that is you run out of file system entries, right? So it may sound like a funny question. It is a bit of a troll, again.
Yeah.
But it's a real life scenario. Again, we had an application that literally would write, I don't know, several thousand files a second.
Yes.
File systems have a hard time keeping up with that. So clearly nobody in this room would ever write something like that. And if you feel
Right.
like you should come back here and ask us why not.
Yes.
And Mike and Ken will beat you senseless with
Yes.
sticks.
So the reason why you wouldn't write flat files is disk I/O, and you have disk space, contention, that kind of thing. Alrighty, guys. So after, if you guys have real life questions, and we can maybe walk through it on where I don't have to like keep turning it over my shoulder. I can actually maybe turn this, and we can figure something out. But thank you very much. And I want to keep this, by the way.
You want to keep the...
Microphone, yes. So I used to work with these guys at one time or another. That's
why they all know each other. All right, so you can totally disconnect. I know a bunch of you guys didn't because I really slacked off today. I had somebody bombard me. Who does not have a ticket?
What do we need a ticket for?
Yeah, you got to get one too. All right, you got them? Okay, cool. Ken, if you want to unconnect your computer, you're more than welcome to. Nope, you're good to go. I got it.
Am I eligible?
You have access to everything. Come on now. All right.
An old ticket that's not going to win. Make me feel included.
So I'm going to stop the stream so I don't troll myself. I'm not doing that again.
We got the troll brigade back there.
I know.
Oh, yeah, she got her app now.
Huh?
I forgot you wrote your app.
Yeah.
I was over here like, why aren't we giving this?
You're like, wait, when?